joke, okay? So you got the cute little anions out there, and the teacher, what's up, Bracken? Good talk. All right, and then see how they're cations are like trying to go through the window? Okay, and the teacher, argon, that's a noble gas, you guys, right? All right, so he like doesn't get it. He's like, oh, gentlemen, what's so attractive out there? He's got a full shell. He doesn't get it. Oh my gosh. Oh man. All right.
That's a knee slapper.
Oh yeah. All right. Calm down, Ian. It's not that funny. Okay. All right. Stop running around the room. All right. You're embarrassing yourself at this point. Okay. All right. Good stuff. Good stuff. So we are going to talk about naming polyatomic compounds today. Now, the first half of this class is somewhat of a marathon in terms of writing your own notes. This is not in your packet. You need to get this on blank notebook paper. It'll be that way for a little while. And then at the end, when we do a bunch of practice problems, that will be one of your worksheets in your packet. Now, I will say, this top section right here, I would maybe just write what I have highlighted, naming polyatomic compounds. And then the rest of these names right here, don't write that. You can ignore that. I'm going to talk about those, but no need for you to write them. Okay? So, yesterday, we talked about binary compounds. And by we, I mean my video lecture in the Tuesday folder. Some of you guys haven't quite gotten there yet because of the PSAT, and then maybe you had practice right after that. I'm not sure. A lot of people were in a lot of different situations yesterday. If that's the case, you want to make sure you get caught up with the Tuesday video. It's in the Tuesday folder. Your questions have been extended, so you can still answer those today. No penalty score or anything like that. But I will summarize briefly what we talked about yesterday. So we talked about binary compounds yesterday. Now, let me see here. Colin, are you aware of what a bicycle is?
A bicycle?
Yes. Last time you checked, how many wheels are on a bicycle?
A two-wheel bicycle, like two?
Yes. Yes, he's got it. 2 wheels. Because a bicycle means 2 wheels. Bi means 2. Binary means 2 elements. Okay? Area doesn't mean element, but the idea is when we're talking about binary compounds, we're talking about compounds that are made of exactly 2 elements. No more, no less. So, for example, these 3 right here I have circled in green are all binary. Why is that? Because there's only 2 different elements. So, CaF2. Now, there's 3 atoms total. There's 1 calcium, 2 fluorines. But there's only 2 different elements. You guys see that? 2 different elements, 2 different elements. And so those are called binary compounds. And here's how we name them. We write the cation name first, then we write the anion name, and instead of writing a normal name like fluorine, becomes fluoride. We just chop off the N and put an I. Nitrogen becomes nitride. Chlorine becomes chloride, so on and so forth. And that's basically what we did yesterday. Now today gets a little goofy, because what do you do when you have more than 2 different elements? Like here, 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 and here. KCN, 3 elements. CAS and O, 3 elements. NaHC and O, 4 different elements. How are we supposed to name those things? Okay, that is where we get the polyatomic ion sheet, which is that goofy sheet. Again, if you didn't see me say this at the beginning of class, this sheet right here is what you're going to need. Okay, so without further ado, let's go ahead and talk about this. So, binary, again, this is a little bit of review from yesterday. Binary compounds are formed between a metal and a nonmetal. Okay? So you got somebody from the left side of the periodic table, somebody from the right side of the periodic table. They were attracted, boom, bond. And with binary stuff, you only need a periodic table to figure out what's going on. Okay? Because you can figure out the charges of different elements. You can know whether metals or nonmetals, cations or anions, all that good stuff with nothing more than a periodic table. And even the name, where you really just have to be able to chop off the end and add an "ide," you just need to see the periodic table name and edit it a little bit. Now, polyatomic, what does poly mean? Can someone tell me what poly means? Yes, sir. Many, right? So in probably your history books where you first heard that, like polytheistic means many gods, so that would be like a faith that believes in more than one god. Polyatomic is talking about many atoms, okay? And so this is when you have many atoms that act as one ion. So you get a cluster of a few elements. 2, 3, or 4 of them, whatever, and they take on a charge as a collective. So normally we just have, oh, this one chlorine is a -1. Oh, this one magnesium is a +2, whatever. Now it's like, okay, these 2 or 3 atoms right here smushed together, they're a -2 altogether. Yes, ma'am?
Where would we find that worksheet that you were talking about?
This polyatomic ion sheet right here?
Yes.
I handed that to you with your Unit 6 packet well, that would have been last week for you. If you can't, I'll put it on Schoology later today, and if you can't find it there, you could also probably just Google common ions to get you through today. Does that make sense?
Yeah, thank you.
Yep, no problem. Yep.
Can I interrupt for like a quick question? Like this was actually good.
Okay.
When you like think we learned the word poly, like you went to poly, like whatever you said in history class.
Theistic?
Yeah.
Uh-huh.
Was polygon not your first go-to?
Oh, well, you know, I never thought of it.
Like 4th grade math.
I just think to myself, the first time I ever remember a teacher explaining, okay, mono versus poly, you know, I just thought, like, history class. First thing that came to mind. I don't know. Good question. I probably did learn about a polygon before. Polytheistic thing. I don't know. Go fish? Is that what you say in this situation? I don't know. All right. All the great questions, of course. Anyways, and these will always be in your polyatomic ion sheet. All right, here's some good news. See this? Huh? You see it? Fall in love with it? Smell it? Caress the polyatomic ion sheet because this is your best friend. Okay, be like, I don't smell my best friend. Well, whatever. All right, the point is, this has names on it and formulas and charges, and you don't have to memorize anything that's on the sheet ever. Okay? You get to a test or a quiz, like this Friday we have a quiz. You're taking this with you. You get nothing on here is meant to be memorized. You always get this for free. Okay? You need to know how to use it, but you never have to memorize anything on here, okay? So I suggest you kind of keep this with your periodic table. I'm assuming most of you don't keep your periodic tables in the middle of the packet. You probably have it like in the folder on the inside of your binder or something like that. I would keep your polyatomic ion sheets right with your periodic tables. Anywho, so let's see here. Let's take a look at this polyatomic ion sheet. Talking about the different parts. Okay. On the left-hand side, you have all the cation ions listed. You'll notice there's one of them. It's called ammonium, NH4, the +1 charge. Let me just go ahead and say this as clearly as possible. Don't sleep on ammonium, all right? Don't do it. There are so many times where people are like, Mr. Pilcher, where's NH on the periodic table? Be like, okay, all right. It's ammonium, all right. And you're going to forget about this ion every now and then. Don't forget, top left-hand corner, there is one positive polyatomic ion. It's ammonium. Don't sleep. Don't sleep. Snooze button for later. Okay? Yes. Now, anions are negative. Let me talk to you guys about this general area. They're in alphabetical order. Okay? Acetate at the top. All the way down to, I don't know what your last one is.
Vanadate.
Vanadate. Sweet. Okay? You'll notice you're always given the name, the formula, and the charge. And there will be some goofy stuff on there. So, for example, you'll notice, what I want to point out. Okay, so like, let me do a little highlighter. Carbonate is CO3 with a -2 charge, not to be confused with bicarbonate, which is HCO3 with a -1 charge. Okay, so you just have to pay careful attention to the wording. You'll also notice little goofy stuff like this. So arsenate versus arsenite. You'll see this all over the place. 8, ite, and there's a bunch of them on there where you'll have two right next to each other. Here's the difference between the 8 and the ite version of a polyatomic ion. The 8 has one more oxygen. I always say it 8, one more oxygen. It has the exact same formula, it just has one more oxygen. So bisulfate has 4 oxygens, bisulfite has 3 oxygens. Chlorate has 3 oxygens. Chlorite has 2 oxygens. Whatever. Okay. Now the 8 doesn't always have like 3 oxygens or 4 oxygens. The point is, relatively speaking, the 8 will always be the big brother of the ite. Does that kind of make sense? Okay. You'll notice things like that. We'll come back to this. All right. So where are we? We're here? Yeah, we're here. Let's talk about how to name these guys. Okay. With binary, 2-element compounds. Which one always has to come first? Which ion? The positive, the cation. Yep. Okay, and that's in the Tuesday video, so some of you guys haven't quite watched that yet, but that's there. The anion always has what kind of ending? You always chop it off and put a I. That's right. Okay. So those are really just the 2 rules of naming a binary ionic compound. Put the positive one first, so whatever the cation is, usually the middle. And then just chop off the end of the second one, put an I, send it to the bank. All right. Now, polyatomic is pretty similar. Like, you still have your positive ion go first. Okay, so that's no different. But you need to really pay attention to the details. Okay? So, for example, nitrate. Can someone tell me what nitrate's formula is on your polyatomic ion sheet? NO3. NO3 the charge of -1. Nitrite, as I just kind of mentioned, it's going to be the little brother. It's going to be an NO2 -1. Okay? There's only one letter difference. This A became an I. What about nitride? And I'll give you a hint. You would have known this one before you even walked into class today, hopefully. Nitride. What's the charge of nitride? Mr. Pilcher, I can't find it on the polyatomic ion sheet. Pilcher. Close to Pilcher, though, right? One time someone congratulated me on my newborn baby. I was like, that's sweet, but that was also Mr. Pilcher. Let me see here.
Oh.
Woo! Nicely done. I don't know who that was. Was that? Oh, that was Mary, I think. Nice. Yeah, that's just normal nitrogen. The -3 charge. Yes, sir. Good stuff. So, nitride. So just be careful. This A became an I and changed the formula. This T became a D as in dog and changed that formula. Okay, so you just have to be really careful with the details. I'm not trying to freak you out. I'm just letting you know that's just how things are named. So you just have to be pretty meticulous with your practice. All right, let's try a couple of these. We'll go with CaCO3, NH4OH. Let's try those first 2 here. Let me see them. I'll kind of walk folks through it. Oh, I don't know. Mohammed, what does Ca stand for?
Calcium.
You got it. Okay, so we're just going to write calcium like normal. So the cations in these, we just write their name and nothing special. You just write the middle name, whatever it is. Now, quick question. Is this 2 elements or more than 2 elements? Total, this whole thing. CaCO3, is that 2 elements or more than 2 elements? More than 2. Okay, the moment you realize you have more than 2, you have to use this sheet at some point. Does that make sense? Okay, so you just need to tell me what CO3 is called there, Mohammed. What is it called? CO3. You got it. And that's what you write. With the polyatomic ion sheet, you don't have to do the whole weird like chop off an N and put an I on it, blah, blah, blah. You just write exactly what the sheet says. Okay? Whatever the sheet says for the name, that's what you write down when you're naming stuff. All right, let's try another one. NH4OH. NH4OH. So Oswald, my first question is this 2 elements exactly, or is this more than 2 elements? NH4OH. It's more than 2, so you know for sure you need this right away. Does that kind of make sense? NH4. What's the name of NH4 again? Don't sleep. Oh, ammonium. It's called ammonium. Yep. It's ammonium. Now, sometimes people forget and they'll look up N and be like, wait, N's supposed to be an anion. And that could be helpful for you. That might help you catch, like, oh, that's right. It has to be ammonium. Because you'll realize that an anion should never go first and that kind of thing. So this is ammonium. And then, Oswald, if you could just look up what OH is on the polyatomic ion sheet. OH. I see what you're doing. I was like, it's not called IO, you guys. Hydroxide, there you go. Boom. All right. Now, why don't we do, like, one more of these? All right, Meg. MgBr. Is that 2 elements exactly, or is that more than 2 elements?
MgBr?
Yeah. Mg and Br. What?
That's 2 elements.
That's just 2 elements, so guess what you don't need? The polyatomic ion sheet. Okay, the moment you see only 2 elements, okay, the polyatomic ion sheet is temporarily dead to you. You do not need it. Does that make sense?
It's
Okay.
my best friend.
What if your bestie? Well, sometimes you have fights with your bestie. All right, anyways. So Mg is magnesium, and instead of bromine, this becomes bromide. There you go. Okay. Any questions currently? All right, so what we just did was, I gave you a formula, you named it. This is a two-way street. If I give you the name, you got to be able to give me the formula as well. And this is a little bit trickier because it does involve a pinch of math.
Oh.
Woo! All right. Boom. Binary versus polyatomic when we're writing the formula. So with binary, we always start by labeling the charge of the ions involved. Oh, that's a +2. Oh, that's a -3. Oh, +1 for sure. Okay? And that's where your periodic table comes into play, those oxidation charges that you wrote in your periodic table, which I believe was Monday. Okay? That's why those are so important. Now, your charges must always add up to what? They always have to add up to what? You got it, 0. Because I need 8 valence electrons, that's why they add up to 0, so I know what you're thinking. Love that. So they have to add up to 0. So remember, when you have a compound, it's sort of like a marriage. It has to work for both. Okay, so both ions need to be gaining or losing the exact number of electrons to become, to have a full outer shell, those 8 valence electrons, that octet rule. And in these, you'll use a subscript if you need more than one. So for example, in that last problem, we talked about magnesium bromide, and we use a subscript 2 right here to say, hey, we have 2 bromines in play here. Now, polyatomic is pretty similar with one change. Hey, so what do you think is the first thing I should do with polyatomic? Label the charge of the ions. Yep, so you need to know the charge of everybody in play. The charge always has to add up to what? You got it. It's going to have to add up to 0, just like binary. And here's the only difference. Before, you just use a subscript to indicate when you have more than one of something. Now, it's a little trickier. You need to use parentheses. I couldn't type the word parentheses in there. It didn't fit. So I just typed parentheses and then a subscript. Okay? So you're going to have parentheses around something and then a subscript. So it might look like that. And I will show you guys multiple examples of this so you can kind of get a feel for what we're looking at. All right. We're close to being done with the notes by hand, okay? Still got a couple more practice problems you're going to have to do by hand, but then we're going to get into the worksheet, okay? So sorry for those poor little wrists of yours that might be breaking right now with all these notes. On your first day back with Mr. Pilcher since, I think it was December 11th, the last time I saw you guys in person. That is crazy! Last time I saw you guys, I was in my 20s. Now I'm in my 30s. Right?
You're so old.
You're old. Yeah, I turned 30 over winter break. Crazy times. Crazy times. Okay. So we're going to try a couple problems here. Why don't you just write Na and put a little space and put O on your paper. Na and O. Sodium and oxygen. And so this was on one of we did the same format on an earlier worksheet. Okay. So the very first thing I need to do is I need to figure out the charges of these two guys when they're stable. Who can tell me the charge of sodium and oxygen when they're stable? Cece?
+1 and -2 respectively.
Look at it dropping respectively on us. Look at you. All right. Yep. Sodium has 1 valence electron, likes to get rid of it, become a +1. Oxygen has 6 valence electrons. It's easier to gain a couple instead of losing 6. So it's -2. All right. Now, I want you guys to pay careful attention to this next part because I think this will be a good strategy that will help a lot of you. So when I'm doing the visual representation, this is important because it shows, this is how you show me that you understand what we're actually talking about. It's not just numbers on a page, but you're actually drawing and showing me this is what it looks like. So I start by just drawing one of each. So I do a sodium +1. I do an oxygen -2. Ian, you may or may not need your calculator for this, but what is 1 minus 2?
-1.
-1. Is that the same number as 0?
No.
No, so that is a problem, okay? Do I need more sodiums or more oxygens?
No sodium.
I need more sodium. So I'm going to plop another one in there. Okay, again, Ian, calculators, you want to hit, clear it out on your phone, you later, whatever. 1 plus 1 is,
2.
minus 2 is,
0.
good gravy. All right, we're in good shape then. This adds up to 0. Looks like we need 2 sodiums and 1 oxygen at the party. So when I'm writing my chemical formula, I put Na, course, sodium comes first because it's positive. I put a 2. Be like, hey, there are 2 of those. And oxygen, I don't need to write the 1 if there's only 1 oxygen. Boom. And Andrew, this would be called what?
Sodium oxide.
Sodium oxide, that's right. Sodium and not oxygen, but oxide. Okay. I hope you saw that this was a binary compound. There's some sodium, there's some oxygen, there's only 2 elements in play. The next one, there are more than 2 elements in play. Okay, so now you should write down NH4 with a little gap, put an N for nitrogen. Faith, what is the charge of NH4 again? Because you don't want to sleep on it. NH4 on the polyatomic ion sheet, that special one. Woo-hoo-hoo! Yeah, don't you sleep on that ammonium. And then, well, I already revealed it right there. And nitrogen is a -3. Okay, and that's from your periodic table because it's a single element. All right, so here we go. All right, I got 1 ammonium, 1 nitrogen. Faith, 1 minus 3, does that add up to 0? No. Who do I need more of? That's right, okay. Okay, that adds up to 0 though, right? If there's a couple of them, is that good? What do I do? Are we at 0 now? Great, okay, so then we can move on. Now here is where people will make mistakes. They're like, okay, so ammonium comes first, it's the cation ion, right? So they're right, all right, I got my NH4, and I had 3 of those. Boom, wonderful. Any problems?
It's not 43.
Right, yeah. This says NH43. 43 hydrogens, okay? That's not 43 hydrogens. We did not just draw 43 hydrogens. We mean 3 sets of 4 hydrogens. And so this is us. That's us right there. We put parentheses around the NH4, and so that 3 applies to everything in there. Does that make sense? If you forget those, you might have an NH43 on your hands, and that's a little problematic. There's only 1 N, so there goes that. I should clean that up a little bit like that. There we go. All right. Mr. Clark, you want to try and name this one for us?
Obviously, ammonium.
Mm-hmm. And not nitrogen, but nitride with a D as in dog. Yep. Pretty good. Pretty good. How we feel about that? A little iffy? I don't blame you. It's brand new and it's kind of a lot of stuff. All right. So we'll try, we'll try these 2 right here. I want you to try sodium bicarbonate and potassium chloride. Let's put about 60 seconds on the clock here. I'm going to randomly pick out a couple of virtual popsicle sticks, and those will be my victims.
Do you have them separated?
No, this is everybody. But, so for example, Bree, I'm going to call on you for one of these. And let's see here, other one. Nope, he's in class. There's Ian. So is Andrew. Oh,
You should call
so is Oshawa. Huh?
You should call him John in the call.
Oh, would you look at that? John, there we go.
Yeah.
All right, John and Bree, I'm coming for you guys on these 2. Make sure you're ready. Okay, 30 more seconds or so. See if you can write down the formulas for these. Sodium bicarbonate and potassium chloride. Sodium bicarbonate and potassium chloride. What's that?
I forgot what is it in nitride.
This last one right here? So you just have a nitrogen at the end. So if we're just dealing with the nitrogen from like the periodic table. So we just chop off the end and make it an I, nitride. If that was like NO3 at the end or NO2 at the end, that's where we get into the A or the I situation. Does that kind of make sense? Yeah. Yep. Teeny bit more time here. See what we can get. Alrighty. Hey Bree, can you hear me? Oh goodness. Oh, please tell me my mic isn't out. Well, Lexi can hear me earlier. Let me see.
Your mic's fine.
Okay. Oh, maybe Bree's just absent. All right. I'll try a different one. There's Ian. Melania, all right. Hey, John, can you hear me?
Yeah, I have a question.
All right, what's up?
So for the potassium chloride thing, how do I figure out the little numbers?
The charges?
Yeah.
They'll either be from your periodic table or your polyatomic ion sheet. It depends whether they're a polyatomic ion or just a regular ion. So it sounds like you need to do a little catching up with the videos, if you're not quite sure what I'm talking about. Okay, all right. Well, I'll bug someone else about it for now. How about... Oh, goodness. Here we go.
Knee issue or something.
Gozer, there we go. All right, hey, Gozer, can you hear me?
Yeah.
All right. Hey, what is the charge of sodium?
11. No, I mean, 20.
Nice, there you go. +1. And then what about bicarbonate?
I'm not sure. What's that?
That's a polyatomic ion sheet. Bicarbonate, alphabetical order. What you got for me, Gozer? Bicarbonate.
Let's see if I can find it.
Okay, someone else help him out. It's -1. That's on your polyatomic ion sheet. It's the fourth one down on the right-hand side. Ricky, did these add up to 0 as they are?
Yeah.
Great. Okay, so we don't have to worry about parentheses or any of that mess. Sodium is an Na. Bicarbonate is HCO3. We write them just like that, and we're all good. Let me see here. Hey, Melania, can you hear me?
Yeah.
Hey, what's the charge of potassium when it's stable?
+1.
What about chlorine?
2.
It's not 2.
Or,
What's that?
-1.
There you go. Yep. Do those add up to 0?
Yes.
Oh, nice. That's pretty convenient. So we just write a K for potassium, a Cl for chlorine. That's it. All right. Here's what I want from folks. I want everyone who can hear my voice live right now. So if you're watching a recording, you'll need to email me. But if you can hear my voice live right now, you're going into the Wednesday folder, and you're getting your participation points by typing in the letter A and hitting submit. You're going to get your free 10 points for being here. And then after that, if you are my in-person kids, I want you guys crank out this worksheet right here. Okay, so this is actually in your packet, so get cooking on this. Once I finish checking in with my virtual folks, I'll come see you guys, okay? The answer key to this worksheet is, of course, in the Wednesday folder, so you can kind of do a couple problems, check a couple, so on and so forth. So virtual folks will be there in a second. Live folks, get your participation points, and then get cooking on this, okay?